In this video, we're still focusing on triangles, and we're going to have a look at the midpoint theorem. The midpoint theorem states that when I take the midpoint of any two sides of a triangle and connect them with a line, this line will always be parallel to the third side of that triangle. Here you can see that point D is in the middle of AB and point E is the middle of AC. Therefore, line DE is parallel to the third side of that triangle. If one of these points, however, is not exactly in the middle of the line, these two lines will not be parallel. If we now further focus on the line that was drawn and the third side of our triangle, you will see that the length of that line that was drawn is exactly half of that of my third side. So if you want to write down this theorem, we can say that if AD is equal to DB and AE equal to EC, then we know that DE will be parallel to BC and DE will be half of BC's length. And when you make use of this theorem, your reason will be midpoint theorem. Every theorem's converse is also true. That means the if and the then, or the part that we know and the conclusion that we make, will be swapped around. So in this case, the converse midpoint theorem says that if I know that a line is drawn from the middle of one of my sides, and this line is parallel to another side of the triangle, then I can accept that this line is connected to the midpoint of my third side of the triangle, meaning that AE will also be the same length as EC. And I can then still accept that DE will be half of BC. So when I conclude that AE is equal to EC, my reason will be converse midpoint theorem. Example 1. In the sketch, AD is equal to DB and AE is the same length as EC. This means that we can make use of the midpoint theorem because we know that a line has been drawn from the midpoint of one side to the midpoint of the other side of the triangle. So we can accept that DE is parallel and also half of the length of BC. This information will help us to determine the value of x and y. I'm going to start off stating that I know AD is equal to DB and AE equal to EC. Therefore, we can make the conclusion that DE is parallel to BC, and we also know that DE will be half the length of BC. My reason for this will be midpoint theorem. Using these parallel lines and my upside down f, I can now say that x will be equal to 30 degrees, and the reason here will be corresponding angles along with my parallel lines. Y is the length of side BC, and side BC is halved to determine the length of side DE, which is 6, and that means that BC has to be 12 centimeters. For this part, we don't need to supply any reasons because we already mentioned it when we wrote down our midpoint theorem. Example 2. In the sketch, BC is parallel to DE and CE is the same length as EA. In this case, we then have our converse midpoint theorem, and we can accept that BD will be the same length as DA. The question here is to determine the length of AB, and to do that, I'm going to start off writing down my converse midpoint theorem. We know that BC is parallel to DE, and we know that CE is the same length as EA. Therefore, we can conclude that BD will be the same length as DA, and they'll both be 6 centimeters. This time my reason will be converse midpoint theorem. And because we now know that DA is also 6 centimeters, we can finally say that the total length AB will then be 12 centimeters.